This is an operational video for SystemsPack and Harry London Candies. This is a system designed and built by Concept and Design Service of Mount Prospect, Illinois. The system uses standard 110 volt electricity and air. This system is designed to feed, cut, overlap, and bring the cut wax paper to the Viper belt. We are currently set up with a motor in place of the Viper belt for demonstration purposes. Loading the material. Take your roll of material, with the material being dispensed from the top, coming off the top of the roll, slide it onto the core, push it up to the edge and pull it back just ever so slightly. Using our core holder, slide that into place and lock it in place by tightening it down. Bring the paper over the top roller and in between the yellow lines, under the bottom roller, and then we're going to go into the nip, which are these orange rollers here. To open the nip, we're going to move the handle to the top position. Now the nip rollers and the floating plate have been lifted, which will allow you to load the material into the system. Push the material through. Make sure it comes out the front. And in the front we also have some guides. Holding it there, then bring the nip down.
Never reach in.
Yes, never put your hands inside the unit. We do not want hands inside the unit by the cutter blade. Turning the system on. All you have to do, hit the green button. The system will then go through a diagnostics. Yeah, angle it, keep it on it. Once it's ready, the main screen pops up, and in the main screen you have a preset. Come back a little. Yeah. A length that it's actually run, a total count of pieces, and our name, Legacy Feeders. The system is currently set for 18 inches. If I wanted to change the length, I hit the arrow next to preset, and there are different lengths that can be programmed. In this particular case we have 18, 17 and a half, 14, 12, 16.8, 18.5. We have F7 and F8 not programmed as of this time. F9 is a sequencing, which I can explain with something you'll never use. And F10 or 0 is to change something. So if I want to program, let's say, F7, which has nothing in it, I would hit the F10 button first. I would then hit the arrow here on the side saying next till I got to the proper F number that I wanted to change. Hit enter. The screen will pop up. And then using the F keys as number keys, program in your length. If that is all you want to do, hit the button, the arrow that says return. Oh, first got to hit enter, I'm sorry. First hit enter. The screen will go back to normal. No longer highlight it. Hit return, and then I can choose F7 as a running program. Again, giving me 18 inches in this particular case. In this particular system, we do have overrides for the cutter. You hit the legacy, the arrow next to legacy. Again, our name will pop up with our phone number. By hitting F1 or F5, it will trigger the cutter. If I were to hit the wrong one, it would not matter, does not send anything out of sequence. And you can hear the cutter making its cut. Hit escape to return to the main menu. In the main menu, if you hit F10, that will put you into the timing screen. Using the two arrows in the middle, we can move up and down this menu. This is for the overlap. At what distance do we kick the material up in the air, and at what time, and for how long? So kick distance, kick time. To change these, you would first hit, once you're in the one you wish, hit enter. Again, it highlights. Once you've changed the number to what you would like it to be, hit enter again. To escape the screen, you hit the top left arrow. On this system, we also have an emergency stop. By hitting this, it will stop the cutter from actuating. We've also supplied it with an extra switch, so if you wish, you can tie it into your conveyor system. On the top of the machine is the air pressure for the cutter. In the back, behind the nip, or in front of the nip roller, in between the cutter. Actually, why don't you cut it for a second? Hit the right button. Located in between the nip roller and the cutting blade, we have a floating plate. As I lift the nip pneumatically, the plate lifts up in the air, which allows you to load your material. This plate is coated with a anti-static UHMW, and on the bottom we have an anti-static UHMW base. This is a very sensitive area of the unit. This is a floating plate, which allows us to feed and continually cut, but foreign objects and heavy wrinkles do create the potential for a jam. Located also inside the back of the unit, you will see two cylinders, one on the right, one on the left, with flow controls. Those are all preset for you from the factory. If you need to adjust them equally. There are numbers to do so. Okay. We will now demonstrate the unit running. Actually, right now we will now talk about the conveyor system. Actually, try that again. We will first talk about, we're going to turn on the machine and run a little bit, and we're going to show you the cut and the pneumatic lifting bar, which gives us our overlap. The cut happens with the activation of this big cylinder and our special linkage. So as we activate the cylinder, the blade goes down and then back up in one direction. Each time we do that, we make a cut. You will then see a 1-inch bar in the front which lifts after the cut has been made and allows for the overlap. We feed out onto a black UHMW tabletop. This again is anti-static, and for timing reasons we're using this to allow us to get a larger overlap. In the front, after the cut is made and after it feeds up, you'll see it be caught by the conveyor and the first screen roller, and then the second. We then have another adjustable plate here which will feed onto your Viper system. Conveyor pressure, or conveyor roll, the conveyor can be controlled through brackets on the left and right side of the belt. By loosening pressure on the two screws in the back, you can adjust the pressure of the roller inside the belt, which controls the belt location. These will be done prior to running the machine at setup and installation. All the rollers that are used on the system are polyurethane. They can be cleaned with a household cleaner like Windex or any alcohol-based cleaner. Also in the front of the unit we have a slot cut. This slot is to allow you to put a wrench in when the cutter is in this position and off, and adjust the height of the blade for fine tuning. The system should never be run without its guards in place. If you remove the front guard, which you would need to do to replace the blade, there is an air switch which will not allow the system to operate. If that switch is open, the system will not operate. What else do we need to talk about? What did I miss? This system uses a guillotine cutter with a cutting stick. The stick must be in place, otherwise the guillotine blade will never be able to make a cut. The guillotine blade comes down on top of the stick. It will make a groove over time.
Off center. Cut.
Yes, it is off centered. To install and replace cutting sticks, there's a hole located on the non-operator side. And when you change rolls, you may want to look at your stick, and if there's a lot of burrs, just take your fingernail and wipe them off.
Those could be potential snags.
They can create a potential snag. I wrinkled the paper. Okay. Also located on this side of the unit is a way of advancing the system manually if you ever want to run our system for testing without utilizing the Viper belt. There is a crank located up in the front of the unit, and as I crank, when I get to the length, it will do its cut and overlap. You must continually to crank and not stop like I did in this particular case, otherwise you will create a jam.